What's up everybody, welcome back to another video. So what I want to do today is talk about artificial intelligence. I want to do a deeper dive into where artificial intelligence started, who started the research, what were some of the technological advancements that led us to today where we have so many large language models, and at what point do we get to AGI, artificial general intelligence, and then when do we get to ASI, artificial superintelligence, and what does it have to do with the singularity? Alright, let's talk about it. Alright, so we know that AI is everywhere. We know that it's being used in pretty much every single piece of software, program, application, everything that we interact with. Basically, every digital aspect of our lives has artificial intelligence incorporated in it. And of course, the poster child for AI is ChatGPT. It is by far the most popular AI platform that's being used by the masses. Now, artificial intelligence has been around for a very long time, but it's been predominantly used by mathematicians, by computer scientists, by researchers, and very large corporations who have the deep pockets to invest in significant amount of research and development. But what is artificial intelligence in a nutshell? Basically, artificial intelligence is making a machine or a computer that is smart enough to perform specific tasks. It involves a lot of deep learning processes and machine learning algorithms. And at its core is natural language processing, the ability to take some of the inputs that you put in and understand exactly what it means, and based on the data that it's been trained on, to be able to give you an adequate response. Now, one person who has been instrumental and pivotal and considered the father of artificial intelligence is Alan Turing. In his 1950s paper, Computer Machinery and Intelligence, he outlines the capabilities or the potential for a machine to be able to have human-like capabilities, where a computer can have the intelligence similar to a human. He figured if a human can have logic, if a human can have reasoning, if a human can do decision-making processes, why can't a machine do it? Well, he was definitely ahead of his time. And in 1956, in the Dartmouth Conference, that's where a whole bunch of researchers and scientists came together. Some of them were John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. They came together in this conference and they set the stage for AI research moving forward. And in 1970, Marvin Minsky told Life magazine that in the next 3 to 8 years, we'll have a machine with the general intelligence of the average human being. So we see that all this work started back in the 1950s and then progressed over the years with a lot of people dedicating significant amounts of time. But the problem that they had was the technological advancements on the hardware side. We could conceive the math and we could do the research on how the brain operates in terms of how do we make decisions? But the problem that we had is that computers back in the day did not have the capability to store commands. They could take instructions and work on it, but they couldn't store anything in memory, and that was a significant limitation. Basically, hardware is the reason why it's taken so long for AI to advance. I mean, taking a look back in the 1950s, it would cost about $200,000 per month in order to rent a computer. And over the years, AI research has been on a roller coaster ride, considering the fact that a lot of money was being invested. Not much progress was being done because the computer technology wasn't there. So for a time there was disinterest in AI, but it would pick up again, go down, and pick up again. But eventually, DARPA, the Defense Advanced Research Projects Agency, invested in the continuing research and development of artificial intelligence. They wanted to be able to have a computer that can translate spoken language in real time. By the 1980s, we finally had expert systems that were used and trained based on experts within particular fields. But a lot of this stuff was still out of the public limelight. There wasn't as much interest by the mass public in artificial intelligence as there is now. But all of that started to change in 1997 when Grandmaster Garry Kasparov lost to IBM's computer Deep Blue. At that point, we started to see these specialized artificial intelligence programs and computers start to overtake human intelligence in terms of a very specific niche task. And a lot of this was made possible because of the advancements and the achievements in computer technology in the hardware area. Finally, the hardware was starting to catch up to our programs, to the algorithms, to what the mathematicians and computer scientists have been working on for decades. Moore's Law, which estimates that the speed and memory of computers can double every single year, finally started to kick in. And that brings us to now. Artificial intelligence is everywhere. And at this point, the masses are starting to utilize AI in a way that people envisioned decades ago. But the question is, with tools like ChatGPT, with Bard, with Claude AI, and all these other AI programs, are they smarter than humans? And the answer is no. They're faster in very specific tasks. And yes, they can beat a chess grandmaster, but that's because they can process so much information in a short time frame. But when it comes to general intelligence, humans are still the alpha. But AI is advancing very fast, and a lot of it has to do with the transformer model. And the transformer model is a very big topic, and I'm going to do a video on that in detail. But basically, we have an input-output type of problem as humans. When we're reading something, when we're learning something, it's a slow process. Take these books right here. If I wanted to read these books, that would take me a while, and then I would have to digest it, understand it, interpret it, and apply it to how I played a game of chess. And the reason is because we as humans, we either read from left to right or right to left, one word at a time. But with the transformer model, it literally takes all the words and reads them at the exact same time. That kind of reminds me of back in the day I took an Evelyn Wood speed reading course. And the idea is you want to be able to understand and comprehend while at the same time reading faster. And in essence, that's what these large language models do. They could read these books faster than you and I. Alright, so now we have a general understanding of AI, how it started, and where we are now with these new modern tools. But when do we get to AGI, artificial general intelligence? Because AI is not really as smart as humans now, it's just fast. But in general, it's still not smarter than the average human. And that's where AGI comes in. And AGI is the point where the machine itself can think and understand and have the general intelligence of the average human being in a bunch of different contexts. Now the thing is, with AGI, a lot of people think we might already be there. There's a lot of conversations and debate going on in terms of, did OpenAI already achieve AGI? And they have something called Q-star, and a lot of people are speculating that that might be AGI in the works. What I believe is that it's a Star Trek fan inside of OpenAI who saw a lot of those Star Trek episodes with the character Q. Alright, if you're a Trekkie, you kind of know who I mean. But bringing it back, are we at the stage of AGI? When will we determine whether or not we've achieved AGI? That is a debate that's taking place with various interested parties. They want to be able to create a test, kind of like the Turing test, to determine if AGI has been achieved. And we're not there yet. At least I don't think we are. I'm not inside of OpenAI. I don't know what Google's working on in terms of Project Gemini, even though they're projected to release it in 2024. What I do know is the limitation is still the processing power, the raw power that's needed to process all of this data. That's why you see Nvidia is making a fortune when it comes to their GPUs, because GPUs are one of the tools that's required in order to process so much of the information and the data and to output something coherent and something that makes sense to people. That's also why you see a lot of investment taking place in the TPUs, the tensor processing units. The speed of development in hardware is one of the bottlenecks. But at the same time, it's also the energy consumption. The amount of energy it takes in order to process, in order to run some of these large language models, is a significant amount. And you see entire data centers being erected with the sole responsibility of handling artificial intelligence. Microsoft has already stated they're going to invest $50 billion in data center development for AI. But once we get to AGI, that means that the computer itself or the AI system or the data center with its large neural network working on an advanced transformer model will be able to process so much information it'll have the capability of the average individual in terms of the intellectual capability. But it still might not be smarter than people per se, especially some of the smartest people out there. That's where ASI comes in, or artificial superintelligence. Now, we still don't know when we're going to achieve AGI, but there is significant progress being made. But once that's made, you're going to see advancements move forward faster. And then what comes next is ASI. And ASI is when the computer or the system or the AI itself is actually smarter than the average person and will potentially be smarter than the people that we consider to be the most brilliant people of all time. These machines will be able to surpass us in terms of critical thinking, in terms of creativity, in terms of logic, in terms of decision making, in terms of problem solving, and even emotional intelligence. And again, the only limitations in terms of time frame to get there right now is the amount of money being invested in research and development, and the hardware that's going to be required and the energy that's going to be required. But again, you see all these big companies are at a race to try to achieve AGI and then ASI. Now, that being said, it's not known if we'll be able to reach ASI within this century. Some people believe we'll be advancing fast enough to get AGI within the next decade, but then we're going to have a slowdown, and possibly by the end of the century we'll be able to reach ASI. But others are a little bit more optimistic and they believe we can get there by mid-century. Right now, it's anybody's guess. Remember what Marvin Minsky said back in 1970 to Life magazine. Within the next 3 to 8 years, we'll have computers that have the general intelligence of the average person. And it's still not there. But once we reach the ASI, artificial superintelligence, what about the singularity? Are we going to be there any faster? Now, the singularity is a point in time where humans are really no longer the alpha. Machines with AI will be far superior to humans. And that's where everybody starts thinking about the doomsday scenario, but we're not there yet. And of course, a lot of smart people, a lot of smart scientists, computer scientists, mathematicians, and people involved in the industry will try to create safeguards. The question is, if the AI is smarter than humans, will they be able to find a way past the safeguard? I don't have that answer. But if we can have an alignment with AI, with ASI, with technology, there's the potential to do things we could only imagine, where we can only think about in terms of science fiction. At that point, we'll be able to travel the stars. We'll be able to potentially cure all medical diseases. We might be able to solve the most complex problems facing humanity today. And we might even create new forms of intelligence that we can't even conceive of. So if you want to get involved in AI, in AGI, in ASI, what programming languages should you learn? Well, some of the most important languages that are used are Python, Java, C++, Julia, Prolog, Lisp. R is heavily used as well. And this one you may not even think of as an important language when it comes to AI, and that's JavaScript. Google is investing a lot of research and development dollars into using JavaScript for AI. Alright, so now we know a little bit more about AI and how close we're getting to AGI and at what point we'll get to ASI. Again, some of the biggest limitations is in the hardware itself. We need stronger, more powerful GPUs. And a lot of investment in TPUs. We also need to have an influx of clean energy in order to handle all the processing of all this data. But AI is here today, we're advancing fast, a lot of money is being invested. AGI will probably be achieved within the next 5 to 10 years. ASI potentially 20, 30 years later. And then the next stage will be the singularity. Again, a lot of this is conjecture, but there's a lot of excitement and a lot of money going into this field. Alright, hopefully you enjoyed this video. If you did, give it a thumbs up. Don't forget to subscribe, hit that notification icon. If you have any thoughts, comments, or suggestions, leave them down below. And as always, thanks for watching and happy coding.